The adrenal glands, or known as the suprarenal glands, are sitting just superior or on top of the kidneys. Now, in reality, it is called the adrenal gland, but there's really two different functions here. You have two very distinct tissue types and two distinct structures within the same gland. So really, it's kind of a 2-for-1, just like the pituitary was. But in this case, it's not an anterior and posterior like the pituitary. Now we have a medulla and a cortex. The adrenal medulla is the inside of the gland. It's the center part. The adrenal medulla is going to be neural-based tissue. So we're looking at more neural fibers. It's a direct connection of the sympathetic nervous system. So think fight or flight, quick response. While the other aspect is the adrenal cortex. The adrenal cortex now is the outside. It's glandular tissue. It's actually 3 distinct layers of glandular tissue. Each layer has its own distinct functionality to it. So they're all looking, though, as a grouping to secrete the corticosteroids. So all 3 layers of the cortex secrete the actual corticosteroids. We'll start with the adrenal cortex. Now, the adrenal cortex and its 3 different layers is what produces the actual corticosteroids. The corticosteroids is a grouping of all the hormones produced here. So by itself, that name is not a hormone. First off, the zona glomerulosa. The zona glomerulosa produces the mineralocorticoids. Now, the mineralocorticoids is a family or grouping of hormones. It's not a single hormone by itself. So if you're saying, well, what hormone is produced by the zona glomerulosa? You can't answer mineralocorticoids. That's the whole family or grouping of hormones. We'll get into a specific hormone in a moment. Zona fasciculata, that's producing the glucocorticoids. Again, a family or a group of hormones. And the last of the 3 layers is known as the zona reticularis, the gonadocorticoids. The gonadocorticoids, also known as the sex hormones, so the gonadocorticoids. Each layer has its own distinct family or grouping of hormones that's producing. So look at the histology of it. You'll see one is an actual histological image, the other one's an artist's rendition. The very top, you have the capsule. That's just the outside of the adrenal glands. Just below that, you'll notice the zona glomerulosa. Now, the zona glomerulosa isn't very thick. It's just this thin layer right up top. So it's a pretty small area there, the zona glomerulosa. We then have the zona fasciculata. That's this. And from there, we go a little bit deeper and get down to the zona reticularis. And that's here and right here, for the zona reticularis. So trying to understand what the different zonas are from external to internal. While the very medulla is the bottom of the image here, the adrenal medulla. So let's start up in the most external. We'll start with the mineralocorticoids. Now again, the mineralocorticoids is a grouping of hormones. It's not just one. Together, collectively, this grouping is going to regulate your electrolytes. Think sodium and potassium is probably the most important 2 in that category. Now, they're regulating them in the ECF. ECF is the extracellular fluid. It's pretty much what's around the outside of the cells. So sodium, for example, is going to impact the extracellular fluid volume, but it's also dealing with blood volume, blood pressure, and other ion levels because a lot of things are based off of sodium. So it's kind of important to make sure we keep these sodium levels in homeostatic balance. Plus, if you think back, we've already talked about sodium in regards to the nervous system and in the skeletal system. They both play important roles there. Potassium, RMP, resting membrane potential. We talked about the nervous system and the muscle membranes. you had to make sure that you could reset back to resting membrane potential. That's potassium. So two very important electrolytes to keep in balance. And that means homeostatic balance. Doesn't mean they're even, because we know that across a membrane you can have different concentrations. But making sure your body has everything needed to set up its own environment. And of all the different mineralocorticoid hormones, aldosterone is the main one we want to focus on. It's probably the most important, if not nothing else, the most potent. Aldosterone itself is going to work by stimulating sodium reabsorption. So if you reabsorb more sodium, that means you're increasing the concentration of sodium. If you do that, water is going to follow. You bring more water in, and therefore you've increased the volume of wherever that sodium was put. So it's helping with increasing water volume. Now this is looking at the mechanisms of aldosterone secretion and inhibition for that matter. Let me blow this thing up full screen. There's a lot going on here. So first off, we're going to have the primary regulators. If you have a drop or a decrease in blood volume or blood pressure, your kidneys are going to pick this up and say, hey, there's a problem here. We need to deal with this. So the kidneys are going to go through and produce renin. Renin then goes through the renin-angiotensin cascade. We're not going to go through all the details of that now. We'll get that later. But that renin-angiotensin cascade will come back up again in the urinary system. But for now, just know renin eventually gets down to angiotensin 2. That angiotensin 2 can stimulate the zona glomerulosa. All right. Second primary regulator is increase in potassium in the blood. Now, if you increase potassium levels, it'll have this direct effect right on the zona glomerulosa. You don't need other receptors, it just works directly on that. So those are the two main factors that can cause the zona glomerulosa to respond. There is a third factor, kind of other factors. Stress. We've mentioned how stress can impact the hypothalamus before. We know that it can cause an increase in CRH, corticotropin releasing hormone. That corticotropin releasing hormone goes to the anterior pituitary. In the anterior pituitary, it stimulates ACTH, adrenocorticotropic hormone. Once you stimulate and produce that, adrenocorticotropic hormone then goes directly to stimulate the adrenal cortex. All right, 3 different ways now that we're stimulating this adrenal cortex for production of aldosterone. The fourth thing here, dealing with the heart, is going to be inhibition, which makes sense because in this case, we're looking at an increase in blood pressure, an increase in blood volume, which is exactly the opposite of what the primary regulator was. Remember, drop in blood pressure, drop in blood volume, stimulate the kidneys to produce more aldosterone. So this is the exact opposite side. So if you have an increase in blood pressure, an increase in blood volume, the heart produces the hormone ANP, atrial natriuretic peptide. That ANP is going to inhibit the actual zona glomerulosa. All right, so all these things are dealing with the zona glomerulosa. Well, what's going on there? The zona glomerulosa is going to basically allow for the production of aldosterone. Production of aldosterone is going to target the kidney tubules. By targeting the kidney tubules, you're going to increase the absorption of sodium. By increasing sodium absorption, the water is going to follow. That means increasing sodium increases water volume. It's also going to increase the excretion of potassium, so getting rid of potassium. And that's why the increase in potassium in blood had a direct effect here. You want to get rid of the excess. All in all, the purpose is to increased blood volume and increased blood pressure. Because remember, the initial factor was a drop in blood volume, a drop in blood pressure. So we're looking at how we modify and how we manage here. So really, there's a lot of factors that can impact aldosterone secretion. And that's only one portion or one aspect of dealing with blood pressure and blood volume. So when we get into blood pressure and blood volume later on in that unit, we'll bring this whole thing, we'll come back again to talk about it again. So aldosterone, kind of important. Next up, the glucocorticoids. Now the glucocorticoids is dealing with blood sugar. The idea is you want to keep it in a relatively balanced aspect. You don't want too much blood sugar, you don't want too little. So we're trying to keep and maintain that level. Now it's also helping to deal with blood pressure because you can activate vasoconstrictors. Vasoconstrictors constrict blood vessels, make them smaller, which means you're squeezing the blood, increasing the pressure. So we're looking at blood sugar and a little bit of helping hand again with blood pressure. So that means both the aldosterone helped and these glucocorticoids are helping. Cortisol is the most significant of the glucocorticoids. Remember, glucocorticoids are a group, not a hormone. Cortisol is a hormone. So what's happening here is if you release ACTH, adrenocorticotropic hormone, you then can stimulate cortisol production out of the adrenal cortex. That deals with stress, deals with different eating activity. So are you eating a lot, eating little? Do you eat every hour? Do you eat every 3 hours? Looking at how this is working. Cortisol is trying to help with the regulation of the blood sugar here. And really, its prime metabolic effects are gluconeogenesis. Now, gluconeogenesis is going to be the formation of glucose from fats and proteins, which means you're not using glucose, you're not using glycogen, you're now using your fats and proteins as the source of glucose. So gluconeogenesis, all coming from cortisol and its stimulation. Blood glucose goes up though, because if you're breaking down fats, you're breaking down proteins to make glucose, you're increasing glucose levels. But at the same time, you're increasing amino acids and fatty acids. Why? You're breaking down lipids. Fatty acids are released. You're breaking down proteins. Amino acids are released. So it's not a perfect utilize everything from fat and lipids, and as well as the proteins, but utilize what you can. Other aspects are released into the blood. Now, gonadocorticoids. The gonadocorticoids are mostly looking at estrogen and testosterone. Now, it's not a direct production because they are androgens. Those androgens are then being converted into testosterone and into estrogen in the body's cells. So they can help with the onset of puberty, they can help with secondary sexual characteristics, they can help with sex drive. Just like what testosterone and estrogen are doing, because the androgens are being produced and then converted into testosterone and estrogen. So the adrenal cortex, 3 different zona, each has its own family or grouping of hormones, and then one specific or main hormone from each one of those groups.